Okay, IED, we're going to talk about activity 2.1.1, tolerate this. And in this entire activity, they're talking about the concept and the idea of tolerances. And what that has to deal with is that whenever you make something or whenever you create something, if you had to make 10 or 50 or 300 of these parts, there's a really good chance that there's going to be some variation involved with that. So we have to think uh, along the lines of that everything that we create and that everything that we try to find out stuff about isn't going to be exactly 100% accurate. So we're going to have to learn how to deal with those variations. Like, for example, if you're recording a mass and you say that it's like 5 kilograms plus or minus 0.02, then that means that that plus or minus is the relative amount of uncertainty you have at the range of the mass at the end scale. Or if you're giving like temperatures, as the worksheet says, and you say that it's like, they can live within a certain temperature on the low end versus a certain temperature on the high end. Those are some tolerances. So in engineering, we use the word tolerance to subscribe to describe what happens whenever we're dealing with a value that has a upper value or a lower value that goes along with it. And I'll show you the different types of tolerances that go with this, because there are three different types of tolerances that can happen as a result of different measurements either in one direction or another direction. So the three different types of tolerances that we have to deal with, or I guess at the very beginning of the sheet, it talks about the difference between, what specific type of tolerances are required. If you're making like children's building blocks and just cutting them out of whatever, you can have a pretty high amount of tolerance for that because it doesn't really matter whether or not they fit perfectly or not. However, if you're trying to send something up into space, or if you're dealing with an engine, if you look at engine parts, they are very, very accurate and they have very tight or very low tolerances. Okay, we normally use the word tight. So tight tolerance means that the amount of decimals that you have for it are a very, very, very minuscule number. All right, so there's a couple of different tolerance formats that we have to learn, and one of them is a unilateral tolerance. And a unilateral tolerance means that one of the numbers is not really allowed to go past that limit, but the other number can go up a certain amount. So you can notice from these two numbers, if you're drilling this hole in this section right here, it says that you can have a diameter of the hole of 1/2 inch, and you should not go under 1/2 inch, but you can go a little bit over. So since this only goes in one direction, this is called a unilateral tolerance, just like a unicorn would only have one horn. Okay. Bilateral tolerance is a measurement that can go both directions. It allows for a little bit on the plus side and a little bit on the negative side. So if you're drilling these holes and it says that you're trying to make something go all the way through, it says that the diameter is zero point 0.5 inches through, and then it looks like the drill depth on the second part, oh yeah, for the counter bore is 0.25 inches plus or minus 0.003. And since there's a plus and a minus in both directions, that is a bilateral tolerance. Okay. And one other way to write it is to just flat out write the upper and lower limits, and those are called limit dimensions. So in this case, if you're drilling this hole, you could say that I need it to be somewhere between 0.505 and 0.495. I would probably say that between these three, you're probably going to end up seeing the bilateral tolerances the most often. However, these are the three different types of notation that could be used whenever you're describing the amount of allowable tolerance for a particular part. And these are normally used whenever you're trying to take things and fit them together. All right, and here's a couple of examples. Like you've got plus or minus zero point zero 0.05, that's going up zero point 0.5 and going down zero point 0.5. And if you're trying to calculate the limit for it, that would be 1.55 because you're adding those. And then the other one would be 1.45 because it would be 1.5 minus zero point zero 0.05, which would come out to be 1.45. So finding the upper limit and the lower limit is pretty much exactly like just doing addition and subtraction. So the math behind it isn't super difficult. We'll do a couple of examples here. Thanks for watching, and we'll talk later.